Hello, everyone. It's Professor McDonald. How are you today? Hi, Valeria. Hi, Daniel. Hi, Joanna. Hello. Hi, Shavsky. Good afternoon. Okay, so we have a few things to look at in the home inbox. We'll look at the agenda as always first. So here we have today, May 3rd. Your question bank for test 4 is due. So if you want extra credit towards test 4 for doing the question bank that was due today, you can do it late for 75% credit. And then tomorrow, practice test 4. And then we're taking our test on Wednesday. So hopefully you guys have sent me the questions that you needed to today in preparation for test 4, and that you're feeling ready or almost ready to take that test on Wednesday. And then we have just the preparatory assignments for the final exam and the final exam on May 10th. Does the extra credit go towards the test? Yes. The extra credit for doing the question bank and the practice test go towards test 4. You can also earn 5 points for doing SLC tutoring sessions. So it's 1 point for each half an hour, up to 5 points total. So between the question bank, the practice test, and the SLC tutoring, you could earn a whole letter grade on your test. Okay, so let's take a look and see what you guys have sent for today. Don't know how to sign up for tutoring, Daniel? You would just go in Blackboard to the SLC online tutoring link in the green navigation menu, and I've included information on how to sign up for appointments. You can also call the phone number, or you can just go to the Palm Beach State website and search for the SLC Student Learning Center. If you just type in, I think even if you just did Math Lab, it's going to pull up SLC Student Learning Center. And then you can choose your campus. And, you know, if you're having any trouble navigating around, you can always call the phone number here. But you see right at the top are the online tutoring times. And I think if you just go to the main page for SLC, which is palmbeachstate.edu/SLC, there's a video right there on how to get signed up for online tutoring. So just go straight to the web page, or you can use the information that I've posted here. And then once you, when you attend your tutoring sessions, you save, make sure you tell your tutor to send you a receipt, and then save your receipts and upload them. For instance, if you're uploading extra credit for test 4, there's an assignment here where you would click on it. I guess I'm not sharing what's going on here. Hold on, let me see the questions. Where is everyone? We do have 22 students in here. Yeah, so as I was just saying, I just wanted to make sure I was still sharing my screen, because I heard a lot of comments. So I was saying you can upload your proof of attendance right here, attach your files. So all I did was go to the SLC online tutoring in the left navigation in Blackboard, and then go down. You can sign up here. This will give you information of how to sign up, and then you can upload by clicking on the title and then attaching your files. the extra credit for the question bank go towards the test? I answered that one. I don't know how to sign up. I answered that one. And where is everyone? I don't know where everyone is. I think most of us are here. I don't know. Seems like we have pretty good attendance today. So, all right, guys. So let's go ahead and look at the questions you sent. Oh, and I will be posting another extra credit opportunity, which is to do a course evaluation and a couple other things. So look out for that email. If you do go on to Panther Web and do a course evaluation for this class, make sure you save your confirmation page. Just take a screenshot of your confirmation page and just hold on to that, because I will be posting another opportunity for you guys to earn some more extra credit. All right, so let's go ahead and take a look at the inbox. I see a couple of questions for the practice test, so I'm going to go to those questions first. Then I see some questions from the test previous lesson, so we'll go through those as well. Okay, so we'll start with the practice test questions. So practice test number 4, question number 1. You are conducting a left-tailed test of a claim about a population proportion. If alpha is 0.05, find the critical value to 2 decimal places. All right, so finding a critical value for a proportion. Proportions are always, any hypothesis tests about proportions and any confidence intervals to estimate a population proportion are going to be standard normal distribution. So it's going to be, your critical value will be a z-score. And so you might want to know how I know that. Well, when you look at the, I recommend using the formula packet and look at the formulas for, there's a few different ways you can know. First of all, on this page, it says z-tests, meaning standard normal distribution with z-scores and the mean of 0 and standard deviation of 1, will be for claims about proportions and also claims about means with sigma known. So that's when you're going to be using z-scores for your critical values and your test statistics. All your boundaries along the horizontal axis will be z-scores in those 2 cases. And then t-tests are only for 1 case. This only is done when we're doing something with means. So for instance, if we're doing a confidence interval of a mean or a hypothesis test about a claim about a mean, that would be the time that you would do a t-test, but only if you don't know the true sigma, you only know S, the sample standard deviation. So in most cases, you're going to be doing a z-test. And another way that you can tell is to look at this formula sheet, and up here it's divided, 1 sample mean for sigma is known. Notice that we have z-scores everywhere. Okay, 1 sample mean where sigma is unknown, and notice we're using the t distribution. T's are there instead of z-scores. And when doing it for a population proportion, again, we have the standard normal and we see z-scores. Okay, so that really is the hardest part about this, I think. This question is just making sure that you know you're looking for a z-score. Find the critical value z-score, okay? And then you want to always sketch sketch the left tail so that you know if your alpha is going to be on the left side, on the right side, or in both sides. So this is left-tailed, so alpha is going to be just on the left side. Let me check your comments. Does it show me in class? What? Yeah. Raquel, yeah, I can see you in class. So we're going to draw this sketch. Okay, that's my z-score distribution. We know this is a left-tailed test, so my alpha is completely on the left, which makes this a negative z-score. So I want to find out what that z-score is. And that's very easy to do with norm.inverse with 0.05 area to the left, a mean of 0, and a standard deviation of 1. That's all you have to do for that one. There are ones that could be more complicated. If it's a right tail, you would have to subtract that result from 1. Make sure to put your sign in here. It is a left tail test, so it should be negative. Okay. And again, directing your attention back to these pages here, the z-tests. Look, left-tailed test, this is how you find your critical value. Right-tailed test, this is how you find your critical value. Notice it's 1 minus alpha, because then when your alpha is on the right, the area to the left would be 1 minus alpha. And if it's two-tailed, notice it's alpha half is what you put into the norm.inverse. So everything's laid out very explicitly here in this formula packet if you take the time to get to know it. Yes, yes. This is the same packet, guys, whenever you want to know what you're allowed to use for the tests. If you go to test 4 learning module, then go down to test 4 folder, your reference packet, materials that may be used during the tests. Okay, so it's all there for you to study with and practice using it for the test. Okay, now let's see what else we have in the message list. Number 4 from the practice test. Okay, that was practice test 4, number 1. And now we're doing practice test for number 4. A political candidate has asked you to conduct a poll to determine what percentage of people support her. The candidate only wants an 8% margin of error. Okay, so these are the goals. Okay, we want a margin of error that's 8%, and at a 90% confidence level. And then they ask us what size of sample is needed. So what are they telling us to do? Estimate necessary sample size to reach the following goals. Okay, that's what we're doing. So these are the goals we want to meet. We have to know how much sample data to collect in order to meet that goal. So we're going to go to our formula sheet. We're going to go down to this page and look down at the bottom where it says sample size determination for proportion. So this is the formula we want to be using, or this one, which they're essentially the same formula, but in one case, you might be given a P and a Q, which we were not in this case. Remember, we read all the information. They didn't tell us what, it just says the political candidate asks us to conduct a poll to determine what percentage of people support her. but they never told us a percentage that we think support her. So we don't have anything to go on. So that's why we would use this version where P and Q are unknown. So let's go ahead and copy that formula. I'm just going to take a picture of it. Well, let's try that again. That's what we want. All right, so now we have the E. So this is going to be Z alpha half squared times 0.25, okay? And then down the bottom we have E squared, so that's 0.08 squared. So we just need the Z squared. So how are we going to find the Z? Well, it's for a two-tailed confidence interval. So as always, we're going to use the confidence level to find alpha. Okay, that's this symbol. Little fish-looking symbol. And then half of that is 0.005. Or excuse me, just 0.05. So we're going to use that to find our critical value z-score using norm.inverse. And we want to make it positive whenever we're doing confidence intervals. So the absolute value, we'll keep it positive. Norm.inverse 0.05, mean of 0, standard deviation of 1. Okay, and then we're going to just replace that in the formula here. So 1.645 squared times 0.25 over 0.08 squared. Okay, so let's calculate that and then we'll have our answer. So I'm going to do a top set of parentheses and a bottom set of parentheses. In the top one, I'm going to do z to the power of 2 times 0.25. In the bottom, I'm going to do 0.08 to the power of 2. Now remember to always round up when estimating sample size, even if you would normally round down, you always round up to make sure you get enough and not too little. So let's see what your questions are. Wesley, there is a due date to the question bank and practice test. So anything that you're working on after the due date will have a 25% penalty to it. Okay, so let's go on p-value and test statistics, Janique. How to find the p-value and test statistics. Okay. All right, let's see what some of these other questions are. Maybe one of them is also answering your question, Janique. Yeah, this one is for finding a p-value when given the test statistics. So this will help us learn the p-value part of it. And this is question number 10 in lesson 13. All right, it says you're performing a right-tailed test. We have a test statistic, z equals 2.14. find the p-value. All right, now you have to sketch it. Don't skip the sketching part, please. It makes a huge difference of how successful or how consistently successful you're going to be, especially for getting the p-value right. All right, this is a right-tailed test. So if you had your critical region mapped out, it would be like this. You would have all of your alpha on the right and your critical value on the right. Then you have this test statistic, which represents the z-score that your sample statistic had. So 2.14, and what we want to know is, does the test statistic fall here or here? Okay, because if it falls in the red, then we reject the null hypothesis. If it doesn't fall in the red, then we don't reject the null hypothesis. Now, typically you would know the alpha, and so that would help you know where the critical value was, and so then you would know where to place the test statistic in relationship to your critical value. So that's going to be hard here because they're having us focus just on the test statistic. So we don't need to really think about the critical value other than the fact that I like to show you just what it would look like if you had your critical regions set up. But let's not worry about the critical value right now, since we're not going to have to decide if we should reject the null hypothesis. But we are going to place the test statistic on the z-score scale right about here, okay, 2.14, about 2 standard errors away from the mean. And then you're going to shade, because it says right-tailed test, you're going to shade to the right, just like you would have done with your alpha. And so this, instead of being alpha, this is your p-value. P stands for probability, and we know probability and area have a correspondence. So we're looking for an area to the right of this test statistic, this z-score of 2.14. So how do we find an area next to a z-score? Under the bell curve, we use the norm.dist, right? And you'll notice that on this packet, again, under z-tests, I have, for a right-tailed test, your p-value is going to be found like this. 1 minus the norm.dist with your z-score for your test statistic, mean of 0, standard deviation of 1, and 1 for cumulative. It's right there. So what are we doing here? We're using norm.dist to find the area to the left of our z-score. And then since we want the area to the right of the z-score, we're doing 1 minus the answer. Okay, so doing 1 minus norm.dist with my test statistic 2.14, my mean of 0, standard deviation of 1, and 1 for cumulative. Now, if this was a two-tailed test, you would need to double this answer. But if it's a single-tailed test, then this is it. Okay. Now, if you forget, look, right down here I have for two-tailed test, norm.dist 2 times, right? So if you forget, just make sure you're using your formula packet. I've designed it with you in mind. All right, so we have just 4 decimal places, 0.0162. Okay, let me see what your comments are. Hi, Joseph, I'm glad you made it in. Do p-value and test statistics. Okay, I thought you cut it in half. Daniel, you cut alpha in half because alpha is given to you in one whole piece. So if it's a two-tailed test, then you take that single piece that represents the area in the tails and you split it up. But when you're finding the p-value, it works in reverse. You get your test statistic boundary, and then you use it to find one single tail area. And just like alpha is supposed to be in 2 separate tails, your p-value is in 2 separate tails. So if you're finding the area just in one tail for your p-value for a two-tailed test, then you have to know to double it. So it's the reverse of alpha. We always get it whole and we split it up. The p-value, we find it in half and double it up. Okay, now let's see what else we have on the list. That was number 10. Let's see, we'll stay on number 13. I think that was all the lesson 13 questions. Let's do, oh, no. There's some more lesson 13 ones down here. Lesson 15 seemed to be a popular one. Okay, and I want to see what the other students said about this question. Nothing. Okay. All right, so we will do that. But I also want to know, before we move on to dealing with confidence intervals again, Janique, you were asking about how to do the p-value and test statistics. So did that partially answer your question, that last one we just did? And then you want to know, see, the p-value and test statistics is different for every question. So I highly recommend watching the videos in the lesson 13 YouTube playlist. Lesson 13 and especially. Sure, lesson 14 is helpful too, but lesson 13, the one that says lesson 13 videos has this lesson 13 YouTube playlist. And I've gone through a lot of different examples using the hypothesis testing guide. Anything that's labeled HTG, you're going to go through the whole hypothesis testing guide on different examples. And the reason there's so many different examples is because one little detail can change from one question to the next, and it's the way you find your p-value is different. And I've tried to map it out as the best that I could for you guys, if it's left-tailed, right-tailed, or two-tailed, but there's other things that can happen in each problem. So it's very difficult to make it to where you don't have to really critically think through these things. So I encourage you to do lots of different examples. And so why I'm saying all that is because when you ask for me to do a question about the p-value, that could, just doing one or two questions doesn't necessarily give us the opportunity to hit home on enough examples necessarily. So I'd like to have you just realize that so that you can practice more. Let me see what this one is about before we go on to the one about confidence intervals. All right, here's one. Test the claim about the mean GPA. So this was from Annabelle, question number 25 in lesson 13. So let's do this one. This is a good one. Okay. Lesson 13, number 25. All right, so test the claim that the mean GPA of night students is larger than 2.9. Okay, so choosing the null and alternative hypothesis, we want to look for one that has the mean symbol. So we're looking for the ones that start with mu. And then we want the GPA that is larger than 2.9. So this one would be the best choice. And that would make this a right tail test, because we always look at the symbol of the alternative hypothesis. And then based on a sample of 60 people, the sample mean was a GPA of 2.91 with standard deviation 0.05. Okay, so it's important to kind of make sure you're following the testing guide. What do we do in the testing guide first? We always start by writing our claim in symbols. Okay, that was that the mean GPA mu was larger than 2.9, then we determine what the null hypothesis is and the alternative hypothesis. If there's no equality in the claim, then your claim falls under the alternative hypothesis. And this is right-tailed test. Okay, then some other things to note are when they start giving us sample, right? So my sample data is that we had a mean, the sample mean GPA was 2.91. So that's X bar equals 2.91. Okay, that's my my sample mean. That's my sample statistic that I'm going to turn into a test statistic by making it into a z-score. I'll take that sample mean and I'll see how far it is from the population mean in the null hypothesis and divide it by the standard error. Now, notice that I'm using S. Why? Because that's what they gave me, right? We're talking about a sample of 60 people. And while talking about that sample of 60 people, we talk about the mean. So that was X bar instead of mu because it's about the sample. With the standard deviation, okay, so still talking about the sample, what's the symbol for a standard deviation of a sample? It's S, right? Not sigma. So S was given as 0.05. And N was given as 60. Okay, so when I use that information to convert my sample statistic into a z-score, I'm going to plug all those values in. And what do I use for the mean? I always use the null hypothesis, 2.9. Because we do all our hypothesis under the under the assumption that the null hypothesis is true. Right? So what we want to know is this test statistic significantly different from the null hypothesis? Because it's obviously different by a little bit, but is that significant? So we want to know what z-score that is and how odd it is to get a z-score like that. What's the probability of it? Is it very odd for that to happen, or is it kind of like, not that big of a deal? Okay, so that's how I'm going to calculate my test statistic, which is going to be 2.91 minus 2.9 divided by 0.05 divided by the square root of 60. So when you do that calculation, let me get this bigger here so you can see. This is what you should have if you're doing it in Excel. So that should be your test statistic right there. And I don't always do it in that order. I just did it in that order today because Janique was specifically asking about the test statistics, so I got kind of focused on that. But you can follow the path in the hypothesis testing guide. Like I've recommended, you get your claim and your hypotheses figured out. You figure out where the hypothesis is. You figure out if it's right-tailed, left-tailed, or two-tailed. You figure out if you're using z-scores or t-scores. And then you go on and you do these steps in order. You use the area, the significance level to find your critical value, and then you calculate your test statistic by converting it to a z-score or t-score, right? And then you use that test statistic to do step 4, which is to find the area in the tail next to the test statistic. I did make a mistake, and I was wondering if anybody noticed the mistake. It's very subtle, but it's very important, because when I go to find the p-value, it's going to matter very much. Let me see if anybody noticed what it is. It's a common mistake that lots of people, or that most commonly you might make for the p-value. So if my x bar is 3.42, the claim would be 3.4. No, Janique, the claim will be whatever it is in the problem. It's not always, there's not always, it depends on what, are you looking at a specific problem? It just depends on what it says. I guess that's what I want to say. Like, I didn't know if you were trying to draw some sort of relationship between them. Okay, got it. Okay. So I need some, I hope somebody can notice. It's very subtle, but there's a mistake I'm making here. And I'm going to try to put it side by side so you can look at the test statistic formulas. Okay. Look at my test statistic formula here and match it up with one of them here. And tell me if you spot any issue. I'm trying to see if anybody can notice an issue with this when trying to match it up with one of these over here. Very subtle, but it matters a lot. You don't see it? Well, what it is, guys, is if you try to match up these formulas, this one says z equals, let me see if anybody else got it. Okay. Matches with the second one, though. Does it, though? Does it match perfectly with the second one? Maybe it's my handwriting that's making it not as obvious. It's that this should be not a z-score, but it should be a t-score, because remember, I knew the sample standard deviation S instead of sigma, right? When sigma is unknown and you're doing a claim about a mean, it's a t-test. So you should not see z-scores in there anywhere. And this is very important, because now it doesn't matter so much when you're doing the calculation of the test statistic, because it works out the same. But when you go to find the p-value, it matters a lot, because when you go to find the p-value, you don't want to use the norm.dist, because it's not a normal distribution. Our sampling distribution is supposed to be the t-distribution whenever sigma is unknown, right? So it should be a t-score, not a z-score. So that's extremely important, because now when I go to do my sketch for my right-tailed test, t-scores across the horizontal axis, and my alpha over on the right, because it's a right-tailed test, so my alpha is fully on the right, and alpha was given as, hang on, I lost my page. This is it. Alpha was given as 0.05 significance. Okay, so now I'm going to find my critical value, which is a t-score. So I'm going to use not norm dot inverse, right? That would be for a z-score, but I'm going to use t dot inverse. And then you can either put 0.05 here and then just put absolute value around the whole thing to make it a positive critical value, because this is on the right, so it should be positive. Or you can do 1 minus alpha, because if this is 0.05 over here, then over here is 0.95. So you can do t dot inverse with 0.95 area to the left. And then what do we need for t? We need the degrees of freedom. Degrees of freedom is n minus 1. So how many samples did we have? We had 60. So our degrees of freedom will be 59. Okay, so I'm following this guide. Now I'm following it. 1, significance level. 2, use that to find your critical value. 3 is usually when you find the test statistic. It's just, you can find the test statistic before, it's just that I've recommended, since you're always given the significance level in the problem, so you can always use that to set up the tail of your test with your critical region, use that to find your critical value, and then move on to converting your test statistic to a z-score and then using it to find the p-value. Okay, so they didn't ask us to find the critical value, but I'm just going to do it anyways here, just so we get a good review. Okay, so there's my critical value. And then now I'm going to take my test statistic that I calculated earlier. And round it to 2 decimal places, 1.55. Now the p-value, this is the fun part. Put up your test statistic on your graph, 1.55. It's to the left of my critical value, which is at 1.67. So 1.55. Now that is a t-score. And I want to find the p-value. P is for probability. Probability means area. So I am looking for the area in the right tail, p-value here, on 1.55. So again, we did a right-tailed one before this. Remember, you've been following this. T-test for right-tailed, p-value 1 minus t dot dist. Right here. This is what we're going to be doing. Right? 1 minus t dot dist, test statistic, degrees of freedom, continuous. So for my p-value, 1 minus t dot dist with my test statistic, my degrees of freedom, which is 59, and 1 meaning true for cumulative. Now, if you're unsure of when to subtract your p-value from 1, you know, it can help to just look at the picture and go, okay, let's say you forgot to subtract it from 1. You got this answer, 0.93. There's no way this area right here, this little green region that I shaded, there's no way that is 0.37, right? Or 0.367 or whatever, depending on where you round it. It's not even going to be close to that, because remember, the total area under the curve is 1. From 0 to the right, that would be 0.5. And this is a smaller region even than that. So my p-value has to be less than 0.5. Cannot be 0.9367. right? And so that's a trigger for me to realize, oh yeah, I was supposed to subtract 1 minus that. And that gives me an answer that makes sense in the ballpark of possibilities, right? Especially if I've set up my sketch, I can look and go, okay, when I go to label this, that seems reasonable. The other answer, not reasonable at all. So we're going to come in and put that in, both of those answers for our question. That. All right, so our p-value to 2 decimal places is 0.06. All right, and then we want to compare the p-value to alpha. All right, so the p-value was larger than alpha, so what do? Look, here's my decisions about if we'll reject the null hypothesis. When we're comparing areas, right, we will reject the null hypothesis if the p-value is less than or equal to alpha, right? So my p-value was not less than or equal to alpha, so I will fail to reject the null hypothesis. You can also tell, since I did the whole sketch, I can also see that my test statistic did not fall in the red rejection region. So again, I would not reject the null hypothesis. Fail to reject the null hypothesis here. Keep going back to that wrong question. So we're going to fail to reject the null hypothesis. Okay, that was a good one, really good one for review, and a lot of different concepts we were able to review in that one. I'm just regenerating it to see if it's always right-tailed. Yeah, it looks like this one's always right-tailed, so we will move on from that one. All right, and then question number 4 from lesson 14. How do we know when it's left, right, or two-tailed? Okay, Valeria, you just look at the symbol in the alternative hypothesis. That should be right-tailed because it's greater, so you would shade to the right. If it's a less than symbol, it'll be left-tailed. If it's an not equal symbol, then it'll be two-tailed. Now, was that your only question, or do we want to go through this? It's another right-tailed test. So since we just did a couple of right-tailed ones, I wonder if we should do a left-tailed one or a two-tailed one. How about a two-tailed one? It's just Joseph, Kiana, and Tina, so you guys can make a recommendation of something else you'd like to look at if you'd like. I didn't get to this one yet. I think I'll do this one real quick and then go on to the other question. So this one was, I think the comment this didn't have was that they were getting a different answer. So I'm just going to run through the calculation to make sure my answer is accepted. You guys have anything you'd like me to do? You thinking about it? All right, so I just recorded n equals 410, p hat equals 0.84, and we want to find the margin of error at a or a 90% confidence interval. Okay, so I know I'm going to need my q hat. If I have p hat, I can go ahead and always get q hat 1 minus p hat. For confidence intervals, it's always two-tailed. So Go ahead and get my alpha and then my alpha half. And then use that to get my z-score. Now, anytime we're talking about P's and Q's, it's always going to be z-scores that I'm using for my critical value. So I want a positive critical value, norm dot inverse on half of my alpha, mean of 0, standard deviation of 1. Okay, now I should be good to go with everything that I need for my formula for margin of error. It's right here. Okay, so I'm going to take my critical value times square root p hat times q hat divided by n, and this is what I'm getting. Three decimals. Okay, so going to 3 decimals, this is 1, 2, 3. Now, the 7 to the right of 9 rounds my 9 up to a 10, and the 10 rounds my 2 up to a 3. So it should actually be 0.03. So I don't know if maybe there was some issue with the rounding on that, but that's what I was getting. So looks good. Okay, so I'm done with that one, guys. Do you have you guys like to do this question? Does this sound like a good one? Would that be helpful to you? We're going to go through and find the critical values, the test statistic. Does not ask us to find the p-value, but we can still do that as practice and do the whole process basically for the hypothesis testing guide. Or is there something else you'd like to do? Okay, well, maybe you guys are just working on something else at the moment. Okay, so why don't you guys let me know if you have any other questions. I'll just be hanging out here, waiting to hear from you.
Professor, I had to speak to you about a private matter. Were you going to be on your office hours later?
Hi, Joseph. Yes, I will. If you want, do you want to chat about it in here in the private chat, or you want to wait till office hours?
It's fine, either or.
Kiana, are you still here? Okay, I don't think Kiana's here anymore.
Okay, yeah, it's fine.
Let me
It,
before you go ahead though, let me stop recording.
okay.